improved granularity translates into improved operations or can improve operations and performance measurements. We've got three great presenters, and Rick Schumann will be in the background helping with questions. Rick Schumann is the GM and VP of INRIX Public Sector. Our three great presenters today is Ted Trepanier. He's the INRIX Senior Director of Public Sector. We have Darcy Bullock. He's a professor at Purdue University. And we have Dr. Steve Remius, research engineer at Purdue University. We've got a couple housekeeping things I'd like to go through before we jump into the presentation. First of all, everyone is muted and will be throughout the webinar. If you have any questions, go ahead and answer your questions in the box within GoToWebinar, and we will answer them at the end of the webinar. We might answer them throughout online, but at least we will address them verbally at the end of the presentation. We will answer all questions. The webinar is being recorded, and you will receive a link to that within the week. You know, usually it's within 48 hours, but you will definitely get it within the week. So without further ado, I'll turn the presentation over to Ted Trepanier.
So greetings, everybody, and thanks for joining us today. I'm going to briefly recap the agenda. So Rose just covered all the housekeeping rules. Thank you, Rose. I'm going to start with a very brief introduction of INRIX, just a couple of slides. I think probably most of you are very familiar with the company already, but we always want to do a real brief intro for those who may be new. Then I'm going to also very briefly recap INRIX XD traffic and some of the benefits of XD. And then as quickly as we can, we're going to hand it over to the folks from Purdue University to talk through case studies on the ground of how INRIX XD is being used in the state of Indiana. Then as we wrap up, I'm going to do a brief review of the INRIX traffic monitoring site, which is a way for everybody who is a public agency to get a free look at the INRIX XD traffic in action in their area. So the introduction to INRIX, I think many folks on the internet are familiar with the company. INRIX is a true big data company focused on movement intelligence with goals of reducing traffic congestion and enhancing mobility globally. The core of what INRIX does is aggregate big data from a number of sources, the backbone of which is GPS source data. So we source data from over 600 different types of fleets and public agencies, mobile devices, and directly from autos through our partnerships with auto manufacturers, and merge that in our technology platform to push out turn the data into a number of services that are focused on different sectors. And the sectors outlined in this slide, the automotive group, the mobile and internet, public sector, which is the focus of today's webinar, enterprise, and media. And so again, INRIX has got the largest network, inputting data into and participating in the services, over 175 million connected vehicles and devices, reporting data to INRIX in real time and utilizing INRIX data services. Coverage now in 41 countries, which will be growing 3 or 4 more countries by the end of the year. And then more than traffic, we are now also pushing in all kinds of mobility-related services, parking data, hazardous weather alerts, fuel data, and population movement analytics, origin destination analytics, all of which enabled by the big data. But the focus of today is going to be XD traffic. And XD traffic is one of the core services in the public sector suite. On this slide, we basically outlined the different services that are focused specifically on the public sector, right? So we produce real-time traffic, actually calculate the speeds on every segment of the roadway every minute, and then we archive that data, right? And that is the backbone of the services that we're going to talk about today. But just briefly, we'll touch on the fact that there are a number of other complementary services and different ways that data can be packaged to benefit the public sector. So things as simple as traffic maps, travel times on signs, the monitoring sites that are used inside of transportation management centers, the historical data that's used for all types of performance assessment and performance reports. It's some, I think, which will be in the news very shortly, and then the analytic platforms. So let's talk for a second about the INRIX XD traffic specifically. So I think many folks are familiar with the traffic message channel segment, or the TMC codes. So traffic message channels and traffic message channel segments have served the industry well for many years, and they continue in production at INRIX. We support all of our services, on TMC codes, but they have a number of limitations. And so we have developed INRIX XD traffic segments to address some of the shortcomings of the TMC codes. And specifically, the most glaring of those are coverage and granularity. And so the INRIX XD segments cover more roads, and segments are far more granular than the TMC codes. I have an example here of a location in California on US 101 to highlight the key benefits. And so as I was looking at the map yesterday afternoon preparing for this webinar, looking for a section of the road that's outside of the coverage of normal detectors between urban areas, I saw a slowdown on Highway 101, US 101. And so I click on it. You can see the TMC code is over 8.5 miles in length. And the color on the map was yellow, which corresponded to the average speed of 30 miles an hour across that section. But as I clicked over on our monitoring site to XD segments and got the additional granularity, I was able to see that there was an intense slowdown that was actually much shorter in both directions. So the hallmarks of an incident out in a semi-rural area. And I click on that segment, and I can see that the segment length is 1 mile, and the average speed is 9 miles an hour on that segment, and it's actually flowing almost free flow up to that point. So again, the accuracy that the added granularity comes into play in action in a simple example. So with that, I am going to hand it over to Dr. Steve Remius from Purdue University to talk us through the first case study. Steve?
Thank you, Ted. First off, I want to thank this is a huge team effort. Darcy and I will be talking to what we're working with the probe data today, with the INRIX data. But there's a huge team involved in everything we do. We have Chris Day, Howell Lee, Debbie Horton with us in the room here. We also have graduate research assistants Maggie McNamara and Michelle Mecker, who help us with the whole cause. And then our partners at the Indiana Department of Transportation have just been a huge asset, and we work day to day with them, and you'll see some examples of how we use this data to assist the Department of Transportation almost every day. Just our brief outline here. I'm going to speak to kind of the evolution of probe data in Indiana, how we began in this market, and how it's kind of evolved. And I'll also talk about some of the Indiana Mobility Report performance measures. And then I'll turn it over to Darcy to talk about kind of the latest and greatest things we've been doing with the INRIX XD segmentation. So one of the big things about Indiana, we broadcast that it's the crossroads of America. This is from their freight plan in 2014, and it's kind of showing that Indiana is the kind of the heart of the freight world, crossroads of America. $600 billion in freight moves to, from, or through Indiana on a yearly basis. What we try to do in the state is make sure that people can get through as smoothly as possible, and the challenge is getting the source that provides us that information in order to help move everyone through the system smoothly. An example here is each one of these red dots represents INDOT ITS infrastructure. And this is pretty similar to other states, but speaking to NDOT, the urban areas are very dense packed with ITS sensors, whether that be radar, in pavement loops, getting speeds and information. One of the things that we've noticed in states is in the rural areas, we struggle to find accurate information, accurate ITS information that can help us have kind of eyes on the ground of what's going on. We have very sparse ITS locations in those rural areas. and it's not really cost effective to deploy them there. Early on, in order to try to get information in these rural areas, we moved in 2009, we began testing Bluetooth MAC address matching, which involved the physical infrastructure of putting Bluetooth sniffers upstream and downstream of different work zones at different areas, matching Bluetooth MAC addresses, and getting travel times. An example of kind of the results of this in this figure here, just showing over an Easter weekend where we had some work zone slowdowns causing approximately an hour of delay on a Interstate 65, which you'll hear about a little bit later today. We kind of moved forward and decided we were going to, go through with some of this, and we started installing these permanent Bluetooth MAC sniffing stations. However, it was very, expensive and kind of not scalable is really what we're going for. It wasn't a scalable technique, especially in these rural areas. This leads us to INRIX, the archive probe data. It was a game changer where we were collecting information from cell phones, GPS, truck telematics, getting these kind of performance measures that really could be the eyes on the ground for what we were trying to do. The great thing about this is broad coverage in the rural areas. It's scalable, and with the new INRIX XD segmentation, we're really getting a high fidelity of data. The shorter segments provide very accurate pinpoint where problems are and when they're occurring. So I'm going to talk a little bit here about the mobility report that we put out. A yearly mobility report beginning in 2011. What we were trying to do is figure out where our mobility challenges were. In Indiana, we have about 2,000 miles of interstate, and it's really big data. We're getting 10 billion one-minute records since 2010, but without good graphics, it's data-rich, information poor. Meaning, we need something that we can use to understand what's happening with all this data. And that leads to our overarching message. It's something that Darcy's kind of instilled on us, which is, it's a quote from Johnny Jones, and it's what gets measured gets done, what gets measured and fed back gets done well, and what gets rewarded gets repeated. And what we really need is to kind of get data to kind of measure performance on the interstate system, on the local routes, and determine where we can do a better job. This really ties with the FHWA MAP 21 program of kind of performance measurement goals. I swear this is the only math slide I think you're going to see today. It's just showing that there is math behind all of our performance measures. There's papers, and I believe in some of the mobility reports there is some descriptions of the math if people are interested. But I feel like a webinar full of math today might bore some people and get some people to sign off. So I'm going to try to avoid this as possible and get to the cool picture, visual performance measures. Everyone loves it. Green is good, red is bad. Where are our problems? So each of the mobility reports since 2011, we've improved these performance measures, and we've done a really nice job of getting executive level performance measures and engineering level performance measures that people can use to figure out where our problems are. This is one of kind of our marquee performance measures, and I'll just step through this. But what you're looking at here is I-65 south through Indiana, and each one of those bars I'm kind of popping up here is a month of hours of speed less than 45. So it's a number of hours of speed where the interstate is operating at less than 45 miles an hour. This really gives you an overall systematic approach to looking at congestion in Indiana. And you can see in the middle of that diagram is Indianapolis, and at the bottom there is the Louisville area, which in the last few years has kind of been the problem child, especially with, we had a bridge closure that kind of caused a 2,600 hours of speed less than 45 in that area. What these performance measures do, this is the 2011 diagram for that same interstate 65 south, but what we can start doing, and I'll do a little bit of an eye doctor test here, is you can kind of start looking at year to year and just going back and forth. You can kind of see the Indianapolis area right there in the center of the screen. It stays relatively pretty close to the same recurring congestion day to day. And in 2012, at the bottom of the screen, you see that the Sherman-Mitten Bridge closure, that closure in southern Indiana, was fixed, repaired, and the traffic, the congestion less than 45 miles an hour was reduced kind of back to a lighter level, which is kind of what we want to see. This is a poster that we actually have created, and what it does is it looks at all of the interstates in Indiana, and we hung these in executive offices and district offices, and really what you can walk by and you can see, okay, where there's no color, it's really everything's operating well under 45 miles an hour. Where there's color on these graphs, that's where we have some work to do, whether it's recurring congestion, construction zones, winter operations. We can kind of just give a general overview of where our problems are. 94 has been a challenge for us in the last year, going through northern Indiana to Chicago. We have some issues in urban areas like Indianapolis, and then we have kind of rural areas too that are actually operating pretty well. And that's something we wouldn't really know without the INRIX XD looking at rural areas and not having that ITS infrastructure. So I'll highlight one of those. This is I-74. It's a very rural, except for a minor stretch that runs through Indianapolis there, which is grayed out in this. But really, you can see there's not many problems happening on 74 through Indiana. So I'll talk about construction impacts. That's something that we've started to really dive into and take a look at. And you can start seeing on a yearly basis, on a temporal scale here, where are construction problems. So let's take a look at the graph here, this bar chart. January and February, you see winter impact, you see higher spikes. March, April, May throughout Indiana is kind of that, gearing up for construction season, probably the best time of year to travel, as you can see, looking at some of these bars. And then June through December, you get that dreaded construction barrel season where it seems like they're all over the place. So you can kind of get a high-level overview of where our problems are and just kind of see what impact construction is having on the Indiana interstate system. This is just to highlight that recurring and non-recurring congestion. The recurring congestion on the right there is those bars, those bands are very similar every month to month, meaning that there isn't much change. It's systematic, and that's where we might want to look into some capacity issues or just that morning commute is the same, and a lot of cities and urban areas experience this. The non-recurring congestion on the left there was actually a moving work zone that was kind of moving down the interstate system there on I-70 westbound. So you can see a few months where that kind of pops out as, okay, there's a problem here. And really this kind of gives you that systematic system awareness of what's happening in Indiana. So that performance measure of looking at what's less than 45. A lot of people have asked us, okay, well, I understand that 45 miles an hour is kind of a threshold that we chose. What's the severity? How many miles are less than 15? How many are less than 25? And that's where we decided to be speed profiles. And the speed profiles are broken up into month slices here, and it really gives you that okay, where is it really bad and where is it kind of bad? And what we can start doing is take a look at, I'll start building this out, but the January, February, March, you start stepping through and you see an interstate system, so an entire 260 miles of interstate in one direction, and you can see a year-long view of where our problems were. You can see some construction zones popping out. You can see some winter operations pop out. You can see that recurring Indianapolis segment in the middle, and you can see that Sherman-Mitten Bridge section there kind of fix up a little bit, and you see less purple later in the year. Less purple is good. Green is great, and trying to just give us that awareness across our interstate system. What we can use these for is we can start seeing from year to year how are we doing, and this is 2011, 94. We had a lot of construction projects. You see in the lower end of this section here, you see a lot of red, a lot of purples, kind of in the summer construction months. That's what it probably looked like approaching or running into Indiana there. You see a lot of congestion in the crossroads of America. 2012, construction was finished. We had a little bit minor tweaking in the May and June months, but it really opened up, and there was a $16 million savings in user costs from 2011 to 2012 in just that kind of 15-mile section of the Borman coming from Chicago. Another thing that this has allowed us to do is rank, give us that kind of systematic, you have where are my 20 worst segments or my 20 worst segments of interstate in the interstate, where's the pain being felt? A lot of these are construction zones. Another way to look at this is we want to see where are section segments the most improved, where do we do the best job of going from a bad section to a good section, that's on the left in green, and where are our most degraded segments, where do we go from where were we good and then went to bad, usually signifying where there's a construction zone popping up or some other issue, maybe a detour or something. What's great about this data, the data set, is the scalability. And we mentioned 600 billion moves in freight to from and through Indiana. What's awesome about this is we can kind of get that overview of what's happening in the country and scale this to different states, different areas. And a few years back, we actually, I believe, we kept Ted up at night trying to send us some data and trying to get some processing going. But we analyzed I-80 from coast to coast for 1 year. And, you can kind of start seeing where some trends are statewide. And we did notice that one thing popped out that was kind of surprising, which was Iowa popped out in December, and we weren't exactly sure why. So we kind of ran to the news outlets, and we found out that December 20th, 2012 in Iowa, there was a terrible winter storm that was really slowed down Interstate 80. You can see that's an actual picture from that storm. And that's just kind of some of the anomalies that can pop out on the nationwide. One of our goals recently, and then I'll turn it over to Darcy, has been to try to make these more systematic, more real time, so that we can get people the information they need as soon as possible, and they can use that information to pull the levers that they have available to make the changes. So a paper that we've worked on this year for TRB has been that same I-80 interstate, but we've actually, Howell has helped us put together a dashboard that does this in real time. So we're pulling these INRIX XD segments, and we're making this okay, where are our problems now, and kind of getting that systematic roll up. And I'm going to let Darcy kind of discuss some of our slides in terms of where we're going with these dashboards and our visualizations and use cases. And I'll turn it over to Darcy now.
Thanks, Steve. So what we're going to talk about now is Steve's laid a nice foundation on the visualization tools that we use, and I'm going to go through 4 case studies, and the last one is based on a case study that's really only been going on for about 2 weeks, so it's very, very current data. And I think kind of a general theme that you may have heard in Steve's material is many times in the transportation industry, it's important to separate fact from fiction. The media oftentimes has a qualitative description of traffic, and it's important to provide some factual data to understand, how bad or what constitutes a nightmare or what is bad. So I'm going to share with you some of that, some of the visualizations and some of those stories. So as we jump into this data, most of the data I'm going to show you is going to be based on we typically use XD data and typically summarize it in 15-minute periods where we take the median of the data, and that's a quick way for us to kind of filter out those transient outliers with somebody pulling over the flat tire or something like that. This graphic you're going to see here, this is what we're calling our traffic ticker. Steve and Howell kind of model this on kind of the stock ticker that you see on the evening news. And the idea is to have some type of 7-day, 14-day trend, and I'll show these graphics several times to kind of show you how your overall system statewide is doing. So if you remember, Steve had that slide earlier that talked about a static poster summarizing for a year. This is important from a system-wide to keep your pulse on how approximate 2,000 miles of interstates are doing. So what you see here, there's several call-outs there. We can select interstates, you can select districts, you can select speed thresholds, you can pick date ranges. That top graphic there, call-out II, this is a winter storm that came through this year around February 1st. And it's a little hard to see in the legend, but it's color-coded there. And two of the districts jump out there, LaPorte and Fort Wayne. The reason this is of interest in all states in the northern climate have fairly significant winter operations, but just not uncommon for Indiana to spend $60 million a year on winter operations. It's important to have performance measures to assess how you're doing, where there are opportunities to improve, particularly as you have new staff coming on. It's really good to give feedback on how long did the storm last, how long after it went did you recover. So I'm going to now, this is a 7-day view. I'm going to show you a 6-month view. So this is exactly the same data view, but now it's looked over 6 months. And if you see that call out II around the 1st, that kind of puts in context that February 1st storm that I showed you on the previous one. Now I'm going to drill down a little bit more in detail. And those two districts are in the northern part of the state. LaPorte is adjacent to Chicago, and then the Fort Wayne district is closer to Ohio. And as that storm went through, you can see the LaPorte district, pick your numbers, about a 1.5 day of impact. And if you see the axis there, 0 to approximately 80 miles of interstate were impacted at the peak of that storm. And then you can see this is an area that often gets some lake effect and snow. You can see some residual impact. And then down below, there's a little bit more detail in terms of which roads and how many miles on each of the roads were impacted. And then we can shift over to the east, the Fort Wayne district, slightly less impact there. Probably at the peak, a little bit more than 80 miles were impacted, but probably a more modest impact as that storm went through, and perhaps quicker recovery. So that's just kind of a quick overview. As you know, the media oftentimes sensationalizes winter storms, and it's kind of good to have that data on, okay, how long did it last? Where are we in the recovery? How many more miles do we have left to be clearing during that cleanup? So it gives a little bit more factual-based data as opposed to the typical qualitative descriptions that we assess winter storms with. Crashes are a significant concern. Incidents on interstates. This I'm going to show you. This is a crash on I-70 that then had a secondary crash, and the burning truck you see there is actually the secondary crash. These plots are really valuable for understanding the severity during the incident, and then doing after-action review on how this incident went. So this particular case, you see the first crash occurred about 1750. 40 minutes later, that back of queue crash happened with that burning trailer. So this is if you think about some of the initiatives that USDOT has underway right now with connected vehicle, this is just a prime case of how probe data can be valuable for preventing these types of crashes. This particular case, we could see it in the probe data for 30 to 40 minutes before that back of queue crash occurred. So wouldn't it be nice if we had some telematics or some smartphone apps in there that were alerting drivers that we have an unexpected queuing condition on our rural interstate, so you can avoid that sort of thing. The other, if you look here at the following day, the incident lasted until the 28th, and I don't know, somewhere around 4 a.m. Traffic restored. You can see the cleanup in this case had more of an impact on the corridor than the actual incident. And that's not uncommon, and I think this is really good to have this data available as you start. Those of you guys that are involved in incident management, It's a teamwork involved public safety, the DOTs, the wrecker operators, sometimes it's hazmat. How do you effectively work together so that you don't create another incident when you're cleaning up the previous one? So these graphics are very effective for kind of those after-action reviews. I'm going to cover now shift. Steve had some dialogue there in terms of construction zones and the impact, and I think what's particularly exciting going on in Indiana is the state DOT is very forward-looking in terms of how can we use this probe data to assess alternative construction zones quantitatively, and then how can we use them to dynamically manage a maintenance of traffic situation that popped up. So this one, and I'm sure this has been done in other places, I personally had never seen it before, but this is a rural section of I-65 which is heavily traveled by commercial vehicles, and there was a bridge rehab project, and the contract was let to close the interstate, the main line, and have 2 lanes of traffic on the section on the ramps there. And Steve showed an earlier data set from 2009 from a Bluetooth case that was probably about, I don't know, 10 or 15 miles north here, and it showed that when you reduced in 2009, and this was without traffic growth, when you reduced I-65 from 2 lanes to 1, you routinely had over an hour of delay on every Friday and Sunday. So this is a section of interstate that's very fragile to lane reduction. So INDOT made the decision here to do these 2 lanes on the ramps and then assess it with the probe data. So if we, and this is up just north of Lafayette, and then I'll compare it with one done traditional way down by Lafayette. So the traffic in this area is somewhere around 20,000 vehicles per day. This is the XD data in the northbound and the southbound direction. There's some slight variations there in the speed, mainly because of how the segment lengths fell just adjacent to the interchange. The key message there, if you look at that, is you don't see any significant drastic reduction in speeds. Had this been that traditional 2-to-1 lane reduction, and I'll show you some of that later on, this would have been several miles of queuing with lots of that 0 to 14 mile an hour purple color that Steve talks about. And the part that was kind of interesting to be able to do this assessment was south of here there was some other construction going on where there was not the luxury of keeping 2 lanes open. And so you can kind of compare and contrast. And this is the bar graph that kind of summarizes those 2 zones. And this was over approximately a 3-week period. That southern zone, during the exact same period that ramp diversion was happening, had somewhere in the order of $600,000 in user costs of delay. And if you look at that White County there, that small bar that's barely visible there, pick your number there. It's in that, $15,000 or so of user cost. Much more modest impact. Not to mention all the safety impacts you get by not having those long queued conditions where you risk back of queue conditions. And this is a photo of some of the queuing in the Lafayette area where they did not have the opportunity to have 2 lanes open the whole time. And this shows just kind of some accumulated costs, and that dotted line there was duration of that ramp closure. And then after that, the job to the south was still going on, and you can see up through the end of July, that had accumulated up to just under $4 million in user costs. So I've talked about 3 things so far: a winter storm, a rural interstate crash, and an innovative MOT strategy for construction. The last thing I want to talk about is an unplanned 42-mile interstate closure in Indiana on I-65. There was a bridge issue that arose during construction. They are diverting, because to avoid diverting traffic into an urbanized area, there's a diversion route that's shown roughly there, is those orange arrows where the exit, traverse around, and then enter back. This is an area that was completely dark for ITS assets. Steve showed a picture earlier of the ITS assets on the interstate. There were absolutely no ITS assets out on this corridor. We worked closely with INDOT. We got a call on Friday afternoon. We worked closely with INRIX to start pulling in the XD data on this corridor, to start pulling together dashboards so we could assess how that corridor was operating during this diversion. This is a photo of one of the interchanges that the interstate was being diverted through. And then this is that traffic ticker graph that I had talked about earlier. And Steve, it's very analogous to what Steve showed with the speeds less than 45, and then the color codes speed profile. So the top graph is by route, which segments of the route are operating below 45, and then down at the bottom there is that severity. Green is good. The purples are the 0 to 14, and you can see some trends there. On the left is the day of the bridge closure, and then I'm going to talk through a couple of the assessments that were done as this detour was scoped and refined during that diversion. So if we look through this, Steve's put together this graphic, and I'm going to build this route up so that first, in the lower right corner, that blue line, I'm going to now draw the next one that goes across State Route 28, and then it goes up along 231, and then it goes along 52, and then it goes up 231 to 18, and then it goes that last leg onto the interstate. So if you look there, we segmented that diversion route into 1, 2, 3, 4, 5, 6 segments. So we kind of have some coarse, high-level performance metrics of how that corridor is performing. And if you look at that corridor in detail, this is another dashboard view that we use, and this is kind of a real-time that Howell has put together that shows kind of back of queue. And 5 hours after the closure, we had sections there where there were 5 to 6 mile queues. One of the things that INDOT did is as they're looking at this data and they're assessing the conditions, they mobilized to install 2 temporary signals, and I've put call-outs in there, one temporary signal at 52 and 28 and the other at 28 231. The pictorial impact of that is if we look here at the blue color, that was the first segment northbound. We were seeing routinely, 5, 7, that first day, 5 to 7 miles of impact before there was any flagging or operation out there. They got state police, public safety out there flagging, had some modest reductions, but you can see by 3 days later, that blue area on that northbound section of 52 had reduced to very modest delays. And then similarly, this yellow area, which was another unsignalized intersection where they had to put an emergency temporary signal in, you can see that those delays are drastically reduced by Monday. It's kind of, those of you who put up temporary signals know the challenge on like getting power companies out there, the locates, those sorts of things. So this was kind of one of those amazing teamwork to see that come together, and then to be able to show the impact in that data. So made a comment earlier on performance measures and the importance of it. And I mean, these are very valuable performance measures to go back to all your partners and say, hey, we all worked together as a team to get this done. Look at what we did. And they're not just elegant, but you pull the temporary signal away together, and you get traffic flowing. And I'm certain that when you can start reducing those queues, you're going to improve safety because you're going to reduce that opportunity for those back of queue collisions on these unexpected queuing on rural sections. And then if we look at this traffic ticker, you can kind of see that first day at a high level, there was almost 25 miles of congestion. By that Monday, after the signals had been installed, now they've moved. The traffic condition challenges have moved downstream. And now that orange area you can see, August 10th through August 15th. Now you're focusing on operational issues along a signalized corridor. There was not the designed to have signal timings for that type of volume. So you can start then drilling down and seeing where are you having long queues. Early on, there was there's no modeling in this. This is out there responding, dispatching, and adjusting signal timings to moderate it. And sometimes it's signal, sometimes it's flashers. This is a section, a rural section where there was a four-way stop, and I'll just play an audio of a dispatch.
1444, which is en route to 231, J-Road 18 is that intersection. Get traffic flowing through there consistently. Ward County has no units today.
So this is that operational aspect. So if we look at this queue, they've dispatched this at 307. Again, this is that whole teamwork scenario. 307, we're seeing it on the dashboard. It's growing. Back queue gets about 4 o'clock, gets maximized, and then they've got it cleared out. And so again, this is an area that was never going to have queuing prior to this diversion. You see it on your dashboard. You work with public safety to get it addressed. And then subsequently, this is that rural, you see in the upper right-hand corner, this is that rural four-way stop. And then you look on the left, this is traffic ticker, that black line. This is where, okay, now that this is serving a major diversion route, that they changed this from a four-way stop to a two-way stop where you've got a flashing yellow instead of a flashing red. And you can see the impact of that, what we're seeing, 4 or 5 mile queues. Now you're down to some modest delays there that are on the half mile. Again, minimizing the risk of those back of queue safety issues in rural areas. And then as you're further fine-tuning the system, the week of August 15th, you can see the orange is reducing, and this is where now they've got a chance to get the system somewhat stabilized. Now you start running common cycle lengths along your corridor. You synchronize your signals to have good progression in one direction. You can see there's some reduction. And then you're looking a little bit ahead further, and no good deed goes undone, so more people start using the corridor, and there's a fair amount of incidents the following week, and you can kind of see things kind of smooth out. And then this last week there was a fair amount of incidents along the corridor that again require significant teamwork to resolve. So we're kind of at that point now where we have gone through several of these dashboards, and I hope the winter storm, the rural crash, the innovative maintenance of traffic, and that unplanned diversion case studies have shown some similar tools, but applied to some diverse operational cases. And I think, as I put a slide up there in the beginning, separate fact from fiction. It's really nice when you can have quantitative numbers and performance measures so that it can be talking about facts as opposed to what are opinions on how the system is done. So with that, I guess I want to reiterate Steve's comment that this is a team effort. We've had a lot of people involved in this. Ed Cox and Jim Sturdivant, our colleagues at INDOT, I'm certain would have been part of this webinar, but they are actively working on this this diversion route as we're speaking. And I also want to thank our folks at INRIX, because they've been very helpful as we kind of very quickly had to pull in data that we didn't plan to get some of these dashboards together. So with that, I'll hand it over to Rick to be our moderator during the Q&A. Oh, I'm sorry, Ted.
We have just a couple more slides, so this is Ted again. as a closing, and then we're going to go to the questions and answers. And so it's an awesome presentation, both Darcy and Steve. And tell you, the traffic operations engineer inside me just loves it when somebody can show with data the good news story. I mean, the teams are out there, working hard to keep traffic moving and prevent crashes all the time, every day across the country. And so it's really neat to be able to kind of see the impact of that shown as real numbers. So I want to just close with a few slides to remind folks that we do have a product that's focused on public agencies. INRIXtraffic.us is a traffic monitoring site that INRIX makes available at no charge, so completely free of ads, and free of cost to all public agencies. It auto refreshes every 60 seconds and shows real-time traffic view across the country. So not only the jurisdiction that you happen to be in, but your neighboring jurisdictions as well. So you can see issues across the line that may be impacting your agency. The basic site that's free is based on TMC traffic. So again, that is good coverage. As you can see in this graphic, this happened to be focused kind of with the state of Indiana in the center of it. But you can see that the coverage is actually pretty good. But as I scroll forward here and we bring on the XD traffic view, you can see the added roads come into play. And so you can see the added coverage. And you can actually see this road closure if you know right where to look in the cross hatches that show this closed road. And I'll just go back and forth this one time here so you can kind of see the difference between the TMC-based traffic and the XD traffic. So the TMC-based view is free, but we also provide a 30-day sample free for the XD monitoring site to anybody who is interested in. So it's a great opportunity to get on the site, and you can actually see the XD coverage. It's in your area, and if the added coverage is going to make a difference to what you're trying to accomplish in your area. In addition to the added coverage of the traffic view, the XD monitoring site also provides a view of our incident layer, as well as different types of traffic views. So you have the congestion view that most folks are used to seeing, the red, yellow, green that correspond to congestion levels. But there's also a view that shows raw speed, so the legend then is basically in miles an hour. And then comparative speed, where the map essentially just shows you what is flowing faster or slower than typical for the specific time of day and day of week that you're looking at. And then there's camera images also available on the site. And so the XD monitoring site is available. Again, that's a premium site, but there is a 30-day free trial for the XD monitoring site. To get on board, all you have to do is go to INRIXtraffic.us and click where it says create an account. The pop-up will come up, fill in all the information. I guess one of the only key thing I want to remind folks here is to use your agency email, because we do a manual approval on these applications, and the site is focused on agency use cases. So Gmail addresses, Hotmail addresses, .outlook, those types of things do not get approved. So we do look at that for that .gov type email address for approval. And so with that, we are going to go to the questions and answers, and we'll leave our contact information on the screen while we close. So if folks have questions that they want to shoot on the side as opposed to having us answer those on the phone, or if you're interested in any of the other services beyond just the free view of the INRIXtraffic.us site, please feel free to drop us an email. So with that, I'm going to turn it over to Rick to moderate our Q&A.
Okay. Thanks, Ted. Thanks, Steve. Thanks, Darcy. Very much most appreciated. So we have about 10 questions so far. I will group them sort of. I'll kind of bring them into families because there's some common themes, as one might imagine. Before I do that, though, let me just point out that I actually just went to the monitoring site and toggled back and forth between TMC and XD and realized that there's at least one stretch of the currently active diversion route that doesn't have a TMC code but has XD. So illustration, again, of the kinds of things that kind of having this higher resolution data, more coverage, just kind of proves the point. So there's a few questions. And those of you here, Darcy, Steve, Ted, you can see these here, but I want to kind of group a couple of them related to kind of the data part first. There's a few questions that probably handle as a group, but first one is mobile data collection using an app installed on user smartphones? And at the same time, there was a question, follow-up question to Steve, as you mentioned, Bluetooth. Interesting data on Bluetooth sniffer approach. Can you please elaborate more on comment on why it was not scalable and or feasible? So Ted, you maybe want to start on kind of where we get our probe data, and then Steve, you can talk about the Bluetooth side.
Great, Rick. Yeah, so on the mobile data collection using an app installed on smartphones, that is indeed one of our data sources, and so INRIX does have a free mobile application. It's actually another good way to look at the coverage in your area. Is simply download the INRIX mobile app, and that does provide a data source to us. We also data provider to other mobile applications, and we get some data back. But it's just that is not a primary source. It is an important source, but again, we add to that with a lot of fleet data and data directly back from our auto clients and the OEMs as well.
So in terms of the Bluetooth data collection, we've done tons and tons and tons of data collection using the Bluetooth system. Personally, I have driven, I think, every corner and every interstate of the state of Indiana dropping these boxes off. And as we all know, time is expensive. So one of the issues with the portable sensors is that there's a time constraint where you have to send people out to the field to install these cases and finding poles and infrastructure to mount these things on. We also experimented with permanent stations where the issue is maintenance. It's physical infrastructure that you actually need to install, maintain. Those costs add up as opposed to just a systematic system which we get from the INRIX data, and we get these predefined segments that we're getting at all times and not picking just a single time study period. And just on that note, I mean, we still do use Bluetooth for these in-depth analysis of looking at one corridor, but for all of our systematic approaches, we're using the INRIX data now.
Okay, thanks, guys. As we transition on, I'll use kind of moderator prerogative. I just want to amplify one point on Ted's discussion. I think it's pertinent for a lot of the work that Purdue and INDOT are doing, is that a big source of our data, particularly in America and developed Europe too, are long-haul freight. Commercial vehicles in general, long-haul freight in particular, which allows us, to kind of distinguish ourselves, the ability to cover a lot of this network that's outside the urban areas 24 hours a day, 7 days a week. Okay, so the next kind of grouping of questions, and they have to do kind of with XD, segmentation, updating, and so forth. So I'll ask them kind of all at once, and then Ted, you can start, and then Steve, Darcy, and team, or anybody else on the Purdue team wants to chime in who has experience with the delightful process it is working with segment data and geospatial data, feel free to jump in. So the questions are, does the INRIX segmentation change yearly, or does the segmentation remain constant across multiple years? That's one question. The related question, how are the segments defined in XD data? There is, let's see, there's at least one more. Hold on a second. Can you comment on standardization of arterial roadway segment codes, or XD codes published in industry effort to standardize?
Okay, so we'll dive in here. So does the segmentation change yearly? So we actually do map updates twice a year. And so while the codes do not change, there can be minor modifications to the codes twice a year. The bulk of the changes are the addition of roads, right? And so we add roads as roads come online, as they grow in functional classification, road becomes more important, more prominent, can be added to the system. We also have the ability to add roads at the request of our clients, and so it was one of one of the issues we had with TMC codes is they didn't cover some roads that were very important to some of our clients, and we really had no ability to add those because we didn't control the TMC codes. So with XD segments, we can't actually add the codes. And so, yeah, so there's minor revisions twice a year. Most of the codes remain constant, though. So then, let's see, how are they defined in XD? And so, again, we have a process that kind of identifies the logical breaks. And I think one of the key points in them is there's a maximum length. Well, we try and keep the nominal length to about a mile. That can be as long as 1.6 miles in length. As I think many folks know, as you get out in the rural areas, TMC codes, they go from interchange to interchange along the freeway. And so if the interchanges are 15 miles apart, you end up with a 15-mile TMC code. And so that doesn't help you pinpoint an incident and know much about if it happens in the center of that section. And so as we're through those rural areas, then we pretty much just, chop up that 15-mile TMC into 15 segments. As we move into the urban areas, we do try and logically break the codes at intersections of importance and that sort of thing. So they do match the system. So there's like some map matching magic that goes on there as far as actual creation of the codes. All right. What else do we have here?
The other question was about arterial roadway, standardization of arterial roadway segment codes. Are XD codes published? Is there an industry effort to standardize?
Right. So I mentioned a little bit about how we try to match them arterials. I don't know that I would call that a standard. We do publish a shapefile of the codes, and so it's kind of the decoder ring for folks to know how to create a layer in a GIS system. You do that using the shapefile. And we do publish an XD shapefile, and that's available for anybody interested in seeing what the codes look like. They're not an industry standard. We talked about that. We're not taking action right at this time to make them an industry standard.
Okay, and again, moderator prerogative, and I'll ask Purdue their view on the segments and their experience. But understand that a lot of us in the kind of the private data provision game use TMC codes to share information. It's not really a standard. One of these things that feels like a standard, but anybody that's ever tried to integrate different providers of data learned very quickly that it's not a fully baked, complete, unambiguous standard, that everybody uses it a little differently, has interpretations. And XD, in many ways, is just a different transform of essentially the similar segmentation scheme. We kind of took the parts we liked from TMC segment schemes and as Ted amplified, improve the granularity, more flexible with road coverage, and provide a shapefile based on OpenStreetMap data that allows us to easier to share this information with customers who are interested in integrating the data. So, guys, your view on XD segments and all that?
So I think maybe my comment would be this is Darcy speaking, is we look at the broader use of the graphics that Steve showed on nationwide coverage. It would be wonderful if the states could find a way to rally around like the maps and populate them with mileposts, because I think that would be a huge value. So I think there's some huge opportunity right now. I'm not sure what that right forum is, but for some states to come together and figure out, because that, as Ted pointed out earlier, the current INRIX data, you can look across the border, but the mileposts, when you start getting into detailed operations, that's where the real value comes, and if there could be some states collaborating on that, that would be a wonderful thing.
Great. Any other comments, guys? By the way, what's remind me the number of kind of the general ballpark of TMC segments to XD segments as far as the analysis tools you guys use?
I think so. When we built the original mobility reports, we were doing interstates only, and we had about 1,000 segments of TMC codes. When we switched over to XD to start building some of these dashboards, we went to approximately 3,000 XD segments, so about 3 times the amount of codes. Another interesting thing has been Indiana's had this major push to build new roads. 231, which is one of the detour routes, as well as I-69 and the Hoosier Heartland project, brand new roads. We're seeing those get populated in this XD segmentation much quicker than the TMC segmentation. So it's really advantageous if you're building new roads, which I know it's a luxury, but it's very nice in the city of Indiana that we're building new infrastructure and kind of living up to our name of the crossroads of America.
Great, thanks. Okay, so a couple more themes I see here. One is something that we expected, and thank you for folks for actually asking these questions related to the notion that these are really cool tools. How were they created? How could they be used? So there's a family of questions. I'll start reading them. Are these visualizations provided by INRIX XD, or are they created by the researchers? Are the data visualization reports that you have shown here available with the XD traffic product? Are they in addition to the UMD analytics? Let's see. And what platform is this data visualized, e.g. web applications, software, etc.? Great info, but appears that much of the data crunching was done by Purdue using INRIX data, but not by INRIX interface. Many agencies do not have enough spare resources to do initial analysis. How do you see this issue resolved? So I'll give a view, and then you guys chime in on some of the questions as well. We have, in a lot of cases, we have customers that take, there's a question here we'll cover in a bit, but Purdue takes the data in real time. So I don't know if anybody noticed, but there was a chart that Darcy showed near the end, traffic ticker that you updated this morning. I saw it. It had August 25th on it. And, the only limitation, the ticker's live, the only limitation is you have to copy it into the screen, into the presentation. But we have a lot of customers and partners that take our data and do cool stuff. Like we don't surmise that we have all the best ideas about how to use this data. Obviously, one of the reasons we've done this webinar is Purdue for years now has been taking the data and kind of stretching it and pushing it and pulling it in new directions. And so we're in active discussions kind of how we can bring this, this kind of stuff. So one general question would be for the audience in the question, just say yes or no, but for us, we need to kind of get a vibe and a feel if there's a market for this kind of stuff. As an extension to the other kind of analytics tools. So if you have a view on that, please feel free just to chime back in answers that will help us understand. But yeah, I think we're trying to understand collectively how we can extend this beyond support for one particular state and one kind of operational approach. Gus?
I think you hit the nail on the head. We're trying to figure out how to work together and extend this. And there's a lot of interest by a lot of states, and I think we're trying to chart that path forward. And I think probably to direct the queries to you guys, because I think what we try to do at universities, we try to be two things, that idea factory to identify innovations that can help agencies do things cheaper, better, faster, safer. And then the other thing, this particular one, when this bridge diversion came up, we kind of put our research hat to the side and kind of went into operations mode with INDOT and how can we pull this together? And I think the part that I think is very cool there, if you look there on August 7th and that was closed, within 5 hours of the closure, we had live dashboards going on the corridor. We never could have done that if we had to deploy assets or something like that. So I think now we're kind of in that spirit of how do we start pulling together a common thread so we're not doing a lot of one-offs on that. And I think we're going to look to you and Ted to help us converge on a vision.
Challenge accepted. We're very excited. You create the XD concept based on a vision, that more granular traffic was needed, better coverage on ramps, better ability to add roads. So it's been in existence for almost 2 years now. And kind of rolled out the product, mature, a little over a year and a half, and I think it's logical to kind of figure out how we continue to extend, bring the functionality utilization within products and services as we proceed. One particular question was asked about the nature of the software used to create create the visualization. So do you guys want to chime in?
Maybe Powell, who's done a lot of the back end development on this, could give kind of a high level overview of that.
Hey everybody, this is Howell Lee speaking. So just a comment on the data platform that we use. So we call the INRIX API in real time, once a minute, and what we do is, so the data that comes back is an XML data source. So we take that and parse it to an SQL server, where we store and archive and do a little data massaging, and then we basically have a web front end on that using PHP to display that data in SQL server.
Great. Okay, so there's a couple of questions around accuracy. So we have three. So let's see here, at least three questions. Let me see here. I'll read them out loud and figure out how to deal with these. Please comment on arterial data accuracy. Are there guidelines for its use, i.e. minimum intersection spacing and traffic volumes, traffic mix, link speeds? Let's see here. Do you ever get rid of a segment if it's not collecting enough probe data, i.e. small primary road in Iowa? What is the difference in accuracy between INRIX floating data and Bluetooth data? Are the floating data more reliable? That's yes. Okay. So, gents.
So this is Steve speaking. I could speak to the data accuracy in general that we've seen, and then some of the kind of more scientific papers that have been published. I know in general, everything we've seen has been very accurate. We did a very, we compare with Bluetooth, we compare with the TMC segmentation, we compare with the XD segmentation. Everything we've seen has looked very nice. Stan Young at Maryland has actually done a lot of testing, and I believe they do testing in real time through the I-95 Coalition and looking at how these speeds are coming in and how accurate the speeds are. But in general, we've seen a lot of that, especially on the arterials. I think Stan has defined some of the signal densities and some of the other things in the literature that are good and adequate to use in terms of the INRIX XD segmentation.
Great. Maybe I'll chime in on the one of, you mentioned, do we ever get rid of a segment if it's not collecting enough probe data? And so I think that really the short answer to that is no. I mean, I don't know universally, but once a segment, kind of always a segment. We do publish metadata that goes along with our data. So we mentioned that we update our data once every minute and make that available in real time. Well, yes, obviously there are roads out there that in the middle of the night, in the middle of nowhere, right, there is no probe data available because there's no traffic on the road. So at that point, we're going to publish a reference speed, right, a speed that we know is the typical free flow speed for that section. So if somebody's using our data to light up a travel time sign or something like that, then that sign is still going to actually accurately portray what travel down that road experience would be like. But we also then publish a metadata field so that if folks are researching, they actually know if we've filled in the segment with a reference speed or a historical profile speed, or if in fact it is based on a current real-time GPS-based data, right? And so we're very transparent about that. So I guess the answer is no. The segment will be there. There will also be a metadata field, so it'll tell you exactly how many minutes of the day that link is populated with real-time data.
Okay, great. And just as a follow-up, Stan Young at the University of Maryland is now at the National Renewable Energy Lab. He's at like 4 different places. But Stan, you can find Stan online through the University of Maryland Vehicle Probe Project. And I think one of the things we've experienced is there's different ways. There's no simple answer. Arterials are complicated than freeways. And it depends if you're trying to put travel times, precise travel times on a very dense corridor. That's one thing. If you're trying to detect general flows and associated with something like this diversion, it's a very different thing. So a lot of it's tied to use case and the nature of the network and so on and so forth. But there's still kind of a lot of evolving thinking there. But every day it gets more useful for more things. Okay, so let's see here. We have one question, how real-time, I'm going to start going question by question, since we're getting closer here. How real-time is the data, i.e. for IDOT analysis, did Purdue get the data in real time, or did the data become available days later? Right now it's real-time. Gents, early days you guys acquired archives from us, but now you take it real time. By the way, just backing up with Darcy's point, one of the difficult things to extend this is simple ways of generating milepost information on the expressways in other states. I mean, there is no simple model that turns all this into milepost data, so you can't press print and immediately take a product nationwide. It's a little more complicated. Not that it's incredibly difficult, but just reiterate that. Next, since it has to do with money, Ted, this is for us. What is the pricing model?
So the pricing model is give us a call, send us an email, because it varies wildly, quite honestly. And so in general, the price varies based on the geography you want covered, right? A bigger area costs more. Based on the use case, right? So the bigger the exposure of the data, and the value goes up, right? And so we provide data to light up travel time signs, which cost, as little as like $1,000 a month, and then we have contracts that are, approaching $1 million a year, where people are doing everything with our data, full access on all roads on very large geographies, and it's kind of scale everywhere in between. And so really the only way to get good pricing is, don't talk to your friend or neighbor, just shoot us an email, let us talk to you directly.
Okay, kind of follow-up question on that. Actually, this is related to the monitoring side. Is the TMC free license provides the DOT the right to use the real-time data, integrate the data into other software, i.e. push travel time to variable message sign?
Right. So Rick knows as well as I do, and the answer is no. The free license that goes with the INRIX monitoring site is specifically for internal agency monitoring, right? So as you mentioned, then to take that data and turn it external and use it in reports or import it into an ATMS system, that is our business, right? And so we do have to charge for those services. Some of them start very reasonably, so just encourage you to contact us.
Okay, let's see here. I noticed that you added a couple. This is a good question, and anybody that's a data person will stutter a bit before they answer the question, because this kind of stuff that you have to deal with. I noticed that you added a couple segments to a road that did not exist before. As a result, travel times for previous years before the addition appear to be lower than they actually are. How do you deal with that with those kind of matters? That's the question. I don't know.
Yeah, no, I don't know. I don't think we added any segments in our PowerPoint or in our.
How about experience, though, guys? You've evolved over the years. If you have to deal with kind of the data integrity as you evolve, as you change and evolve, how do you deal with that?
So some of the things that we've done is you can come up with performance measures as opposed to looking at a segment by segment technique. You can actually weight the segments by distance, and as you weight segments by distance, you're kind of solidifying them to a roadway, and those numbers add up pretty close. We've done some comparisons between, okay, what do the TMC segments say across the interstate system, and what do the XD segments say across the interstate system? And for our real-time dashboards, the XD segments are smaller and more accurate, and especially when we get to congestion conditions. However, the general trends in terms of looking at the TMC data and the XD is similar, but the XD data provides that real time, especially with that delta speed, backup queue, congestion. It pinpoints exactly where we need to be, where we need to kind of send resources. But I hope I answered the question. I know there's so some of the changes in terms of the changing XD segments or in XD segments can be kind of taken care of with some weighting.
Great. Okay. Next question here. Has this data ever been used for monitoring speed enforcement performance? The Purdue and Indiana folks can answer, I'm sure, from your perspective.
Yes, we've done that. We've done that looking at the variable speed signs, and we've got a TRB paper coming up on that. So yeah, it's the issue is I think we've been looking at it from the perspective of, can we use variable speed limit signs to effectively influence approaching traffic to a work zone? And yes, we can see measurable impact on that. We have not crossed into the path of enforcement action. We've been looking at, if they invest in variable message signs, are they influencing traffic speeds? And we've seen that in the data.
Yeah, another study we've done, we've looked at kind of some of the aftermarket or out on the market speed, spot speed measurements, and just done some general comparisons of looking what the INRIX data says versus what some of these products on the side that you put on the side of the road, and they've matched more or less pretty well.
And Ted, I'll chime in. You want to jump in? So, again, in the product portfolio, kind of the real-time data isn't, particularly if you're thinking about interstates and stuff, we don't focus. We spend a lot of time trying to identify congestion, and we're not so worried about, we do a lot of things with our free flow speed, kind of at a high end. We're not broadcasting 80 miles an hour as a free flow speed out there, because things that would take travel times and all that into account would not. So we have products, we have profile-related data that if somebody really wanted to do that, they probably could dig in and find some segments that tend to go towards the more aggressive driver route. But I'm not all that aware of many people that have taken this kind of data and kind of gone in that direction with it. Some of that stuff can be a little dicey. Okay, can this data be used to produce origin destination studies prior to major construction zones to optimize alternates? I don't know. Never asked that question. Thank you very much. That's a terrific lead-in.
Right. Exactly. So not so much actually XD data the way the real-time traffic data that we've talked about today, but we do have other products that are actually better aligned for origin destination type studies, including trip records with waypoints. And so the core GPS data that gets reported to us, we can roll up in a number of different ways into different solutions and mine different type of information out of it. And so origin destination is one of our emerging product lines that's getting quite a bit of interest. And so we can create traditional origin destination type matrix, and we can create matrices that are specific to certain corridors. So say, give me a matrix where it shows just the trip that goes through this zone, right, that I'm thinking about rebuilding and that sort of thing, so you can better model the impact of that. And so those are products we have, right? And so not necessarily associated with XD segments, but in general, OD associated with pretty much whatever kind of a zone structure you as a customer want to define.
Great. Okay, the next question. Does the XD data include imputed values? Does it tell us how observations occurred during the report periods? So
yes and no. So as with TMC-based real-time traffic, the real-time traffic product is an imputed product, right? We're taking in millions of individual observations through a very sophisticated mathematical model that is the INRIX Fusion engine, and doing a calculation that is our best judgment on what the speed is on every minute of the roadway every minute, right? And so that actually is an imputed product, with no question. Now, as part of that product, do we publish how many points are used in that? No, we don't. And there's a lot of reasons for that, but it's quite variable, and there's a whole lot of things that go into the secret sauce and the special services. We tend to look at the accuracy, right? And we have our clients look at the accuracy of the output, which is a lot better measure of the product than trying to judge it based on the number of points on the input side.
And I would just add, we have two metrics that we do pass that kind of are used and can be used to help identify indicators of what is the data. We have a thing called SCORE. There's different values of that will tell you if we're providing you a real-time reading, or as discussed earlier, if you're on a rural road at 3 o'clock in the morning where there not be any vehicles for the last minute, we revert to historical, and we'll tell you that. And then in our real-time data, we'll actually give you a confidence value rated 0 to 100 as well. And depending on the sophistication and desire that folks have, some folks use those various things to decide what to do in various applications. But again, it all comes down to what's the output, what's the quality of the output. And we published on our site, we've got a report that was a summary of the I-95 vehicle probe project reports over 6 years. You search for INRIX I-95 VPP report, quality report, and you'll find it, or get sent to the University of Maryland site that has all the 40-some-odd tests. Okay, next question. Hello, what needs to happen for XD segments to be mapped for other ITS networks, for instance, South Africa? Ted.
Well, so that's a good question. So I believe we actually have some services there, and so it's basically just demand, right? And do we need to, is our product demand there? Certainly if you're in charge of a country that's not one of the 41 that we already are producing data on.
South Africa is. I mean, we're live in South Africa.
We are. It is live service in South Africa now, and so
we have
now there is it's not, I don't believe, visible on the INRIX.US site, but there is I think it is visible on the .eu site. Yeah,
for folks that are not in the Western Hemisphere, we have a companion. Everything that Ted said about a monitoring site applies. There's a European version, well, a non-American version that we branded INRIXtraffic.eu, and you can go and, in fact, I'm double checking. Well, I'll confirm this, but you can actually see the coverage live and the same things apply. Free monitoring site. And subscription-based service for the higher featured XD monitoring. What is the coverage outside of the U.S. for INRIX? It's a straight expansion of the last question. Ted, we're live in 41 countries?
We're 41 countries today, and in a couple of months we'll be adding 3 more.
And the specific one here said i.e. Canada and UK, yes and yes?
Yeah, excellent coverage in the UK, very good coverage in Canada.
Correct. And again, the mobile app, I was just in Germany over the weekend, and my mobile app I downloaded from the U.S. App Store worked just fine, showed me the German coverage. So if you want to download the mobile app too, that's another way to see coverage in most places but China. China's a different animal.
Right.
There's a whole set of things. If anybody's ever tried to do work in China, there's a whole set of things. We're live in China, but we can't show you here.
It's not on the mobile app.
What measures do you take to ensure the authenticity of data before using it to contribute to the analysis? So I think we've answered from our side. What do you guys do? Is there anything you do with the real-time, non-real-time data? What techniques do you guys use as far as within the analysis?
Howell can touch on it in a sec. I think from our standpoint, early on, we were only using the real time, so the score system that Rick had touched on earlier, we only used the assured real time measures, and everything else we assumed it was operating at free flow due to low volumes and everything. It was kind of a conservative estimate. In terms of what we're doing now with our dashboards, I'll let Howell kind of touch on a little bit of that, but I think Howell.
So Steve, let me chime in here. So effectively, you have your data coming in from INRIX, and some of them have scores of 30, which we know are real data points coming from the roadway for that minute. And then what we do is, for these dashboards and visualizations, I mean, there's a lot of data out there. So what we try to do is we really try to reduce some of that data, from minute by minute, because we know we want to keep those, very fine records, but we want to also be able to visualize and be able to display these performance measures very effectively and efficiently. We don't want to be juggling millions of data records on our Chrome or Internet Explorer at any given time. So what we do is we reduce the data in 15-minute bins, and we take the median, and that makes it much more efficient and for performance, and also the graphics to turn out faster.
So the way my non-mathematical mind interprets it is that if you took 1 minute TMC segment data, you might end up with the same amount of granularity as 5-minute XD data, so forth. The granularity of the segments is more important in the analysis world than turning 1 minute into 15-minute averages. 15-minute XD is better than some lower number of minutes TMC for the same number of bits and bytes. It's kind of decisions you guys have made. Okay, we just have 2 more questions. I know we're out of time here. You mentioned a shapefile for the data. Is this just for those using the XD data? If not, is it something that is purchased on its own?
So it really is intended to be, right at this point, a companion product for our customers, typically provided free with a service that we provide. So again, if you have a use case, just encourage you to contact us. We're not really in the business of selling the XD shapefile. It's really a tool to allow the mapping of our data.
Correct, and again, we base it off of the OSM OpenStreetMaps map, which allows us to share it more liberally with our customers than a commercial map might. How do we go about downloading the XD or TMC networks that you're using?
Right, so the networks, again, is essentially we're talking about downloading a TMC or XD table shapefile, right? And so those are products that we typically post up for whatever geography you're interested in on an FTP site. And so it does require you to contact us individually, let us know what area you're interested in, whether it be a city, county, state, or the entire country or group of countries, right? So then we can bundle up the right level of data for you. And then we basically email you a link to an FTP site, and then you can download the file.
Okay, so that are all the questions that we have, I believe. There was one question about, actually way up at the beginning, Rose and Ali, PowerPoint copy for download. We provide the link to the webinar. Is that correct? So anybody can basically view the entire recording and get the words and the context behind it.
And that'll go out automatically within 24 hours of the close of the webinar. So look for it tomorrow morning. But it'll come automatically from the go-to webinar platform, and then we will also make it available on our website at INRIX.com on the public sector industry page.
But of course, feel free to forward it to folks. Obviously, we have as much interest as you all in sharing this information with like-minded individuals. Finally, just kind of closing, there were a few folks that responded back, yes, there's demand, there's a market for these visualizations. I can tell by the number of people that have remained with us from the start to the finish that's the case, but thank you for those of you that have chimed in. So as I said earlier, challenge accepted. We're going to figure out how we internalize. If anybody thinks about these things, trying to translate something from something that very creative people can do on a large scale, but not uber large scale, turning that into a product that works in South Africa. The stuff takes a little thinking and work to do, and you're at the early stages of that. But stay tuned. And again, I just want to say, I guess I'll kind of close up here with folks. Just thank everybody. Thank the team at Purdue and in Indiana for both the years of working with us and kind of taking the original data and bringing it to where it is. And I can tell you, as somebody that's been in this business for 25 years, when I see like what you've done just in the last 3 weeks, with taking this data and actually putting it, you're affecting people's lives in a positive way, and it's fantastic, and we really appreciate that. And anybody else has examples of things that they do, please let us know. We're more than happy to share this kind of the broad user community. But thanks. I don't know if there's any other final comments from folks. No? Okay, with that, I think we'll close the webinar. So thank you very much.